Let's look at how constants affect the mean, variance, and standard deviation of a random variable. Let x be a random variable, either discrete or continuous, with mean mu sub x, variance sigma sub x squared, and standard deviation sigma sub x. If a and b are constants, then the new variable, ax plus b, has mean a times mu sub x plus b. In other words, it's going to be a times the mean of x plus b. Variance a squared, sigma sub x squared, and standard deviation, absolute value of a, sigma sub x. Notice that we could obtain this formula from this formula. Standard deviation is the square root of variance, and so if we just take the square root of a squared, sigma sub x squared, we get this, absolute value of a, sigma sub x. For example, let x be a random variable with mean mu sub x equals 10, and variance sigma sub x squared equals 36. Find the mean, variance, and standard deviation of 4x plus 7. Again, the mean of ax plus b is a, mu sub x plus b. The variance is a squared, sigma sub x squared. The standard deviation is absolute value of a, sigma sub x. Here, a equals 4 and b equals 7. The mean is a, mu sub x plus b. In other words, a, which is 4, times mu sub x, which is 10, plus b, which is 7. So 4 times 10 plus 7, or in other words, 47. The variance is going to be a squared sigma sub x squared. In other words, it's 4 squared times the variance, which is 36. Notice that the symbol for the variance is sigma squared. So we don't need to square anything to get this. It's already been, quote, squared. So our variance is 36. So we don't want 36 squared here. We just want 36. And so our answer for the variance is going to be 576, 16 times 36. The standard deviation can be obtained using this formula. So it's the absolute value of a times sigma sub x. Absolute value of a, that's going to be 4. If the variance is 36, then the standard deviation is going to be the square root of that, in other words, 6. So absolute value of a times sigma sub x, that's 4 times 6, that's 24. Another way to solve it is by using the fact that the standard deviation is just the square root of the variance. So if the variance is 576, then the standard deviation is the square root of 576, which is 24. So whether you use this formula or simply take the square root of the variance, you're going to get the same answer. It doesn't matter. Why doesn't b affect the variance? Notice, it doesn't matter what b is. It affects the mean, but there's no b in the formula for variance. It doesn't even count. It's because adding b shifts all the values by b and does not affect the variation in the values. So however much variation there is in the values, that's not going to be it's not going to be affected if we shift all the values, every single value, by the same number, b. You're still going to have the same variation in the values. So b doesn't have any impact on the variance whatsoever. Okay, how about 2x? Let's find the mean, variance, and standard deviation of 2x. Here, a equals 2. There's no b, so b just equals 0. The mean is going to be a times mu sub x, which is 2 times 10, in other words, 20. The variance is a squared times sigma sub x squared, so that's 2 squared times 36, in other words, 144. And the standard deviation is the square root of 144, which is 12. Okay, let's extend this. If x and y are independent random variables, whether discrete or continuous, then the expected value of x plus y is the expected value of x plus the expected value of y, and the variance of x plus y is the variance of x plus the variance of y. For example, let x be a random variable with mean, okay, we saw this just a moment ago, mean is 10, variance is 36. Let y be a random variable with mean 19 and variance 49. Sigma sub y squared is 49. Find the mean, variance, and standard deviation of x plus y. The expected value of x plus y is the expected value of x plus the expected value of y. In other words, it's the mean of x plus the mean of y. So that's 10 plus 19, or 29. The variance of x plus y is the variance of x plus the variance of y. In other words, it's going to be 36 plus 49, or 85. The standard deviation sigma is the square root of the variance, sigma squared. So it is square root of 85. In other words, roughly 9.2195. Note that the variance of x plus y is the variance of x plus the variance of y, but the standard deviation of x plus y is not the standard deviation of x plus the standard deviation of y. So if you want to compute the standard deviation of x plus y, First, you need to find the variance of x plus y, and then take the square root of that. Let's extend this a little further. Let x and y be independent random variables, discrete or continuous, and let a and b be constants. Then the expected value of ax plus by is a times the expected value of x plus b times the expected value of y. So, in other words, we can pull the a and the b to the outside. So we can break up the sum and bring the a and the b to the outside. And the variance of ax plus by is a squared times the variance of x plus b squared times the variance of y. And note the squares on a and b. Again, let's keep these same values. So mean of x is 10, variance is 36, mean of y is 19, variance is 49. Find the mean, variance, and standard deviation of 3x plus 4y. Here's the formula for the expected value, that is the mean. And in other words, we've got a equals 3, b equals 4. The expected value of 3x plus 4y is 3 times the expected value of x plus 4 times the expected value of y. In other words, it's 3 times 10, the mean of x, plus 4 times 19, the mean of y. So that's 30 plus 76, or 106. The variance of ax plus by, okay, we've got this formula here. So the variance of 3x plus 4y is going to be 3 squared, again, a is 3, times the variance of x, plus 4 squared, b is 4, times the variance of y. So in other words, it's 3 squared times 36 plus 4 squared times 49, which turns out to be 1108, 1108. The standard deviation is the square root of 1108, which is roughly 33.2866. So again, let the mean of x and the variance of x be 10 and 36 respectively. Let the mean of y and variance of y be 19 and 49 respectively. Find the mean, variance, and standard deviation of 3x minus 4y. Well, the mean will be different because in this case, b equals negative 4, not like 4 in the previous problem. The expected value of 3x minus 4y is 3 times the expected value of x minus 4 times the expected value of y. So it's 3 times 10 minus 4 times 19, 30 minus 76, which is negative 46. In the previous problem, this was a plus, so this was a plus, but not here. The variance, however, is not going to be any different. The variance of 3x minus 4y is going to be 3 squared times the variance of x plus negative 4 squared times the variance of y. That is, in other words, 3 squared times 36 plus negative 4 squared times 49, which is 1108, because negative 4 squared is the same thing as 4 squared. And the standard deviation is just going to be the square root of that, namely 33.2866 roughly. So really, it doesn't matter whether it's plus 4y or minus 4y. Strangely enough, you're going to get the same variance.